Good morning all. Today I thought I'd just have a play with this old project, and it is quite old. It's early 1990s. Quite clearly it's a matrix of LEDs, and it's just a message display. You can just put messages up on these LEDs. It's Z80 based, so Z80 A, I think. Is it Z80A? I don't know because it's covered in dust, so I'm gonna have to brush the dust off. Actually, let's do that now. Yeah, Z80A, I think, microprocessor. Yeah, so Z80 running at 4 megahertz. That'll be a 4 megahertz crystal. That's the EEPROM. I was a bit concerned that with no cover on the EEPROM over the years, the program would have been lost, but it doesn't seem to be. That's a RAM, and then there's just a bit of support logic. So I've powered it up from my solar power system. It's got 13 volts. Don't think it was ever meant to have 13 volts. This heatsink, I remember, gets quite hot because it's taking, well, the 13 volts which drives the display section down to 5 volts for the microprocessor section, and of course the Z80 did actually use quite a bit of current. This is the reset switch, and right next to the reset switch is this. It's a blue LED, and it's the first one I ever bought, and it's really dim, you can see there, and it's really pale as well. But yeah, if I reset the unit, you might just be able to read matrix display warnings, but it doesn't really help that I'm backlighting this. So I'm just going to shut the blinds. Right, I've shut the blind, but it's not hugely better. You can read it a bit better. Maybe if I get some of these bits of black foam rubber, I don't think they're conductive, and shove them on the back of the display, that would be better. Oh, that's much better. Matrix display warnings. Cool. Now you can, of course, put your own messages on here, and when we designed this, me and my friend Brett, we came up with this 5-finger keypad. So you put your 5 fingers on there and then just press combinations of keys, which gives I think 31, because obviously all off is not really a command, but 31 different commands to send to the CPU, and 26 of those were letters, and then there was like a shift. I can't remember much about it. I can remember hello, HELLO, I think, but I don't remember much else. And I seem to have lost the 10-pin cable that goes from this keypad. It's simply 2 lines per switch that goes from this keypad up to the CPU. However, I have found this, which was for something I must have made years ago. That's 10 pins. That's a 10-pin Molex, but I do have this, which is an IDC insulation displacement connector. So I should be able to crimp that onto this cable and thus make up the required cable for keying stuff into this unit. But even without the keypad, I think there's a couple of other things I can do, because these switches, they're marked 1, 2, 3, and 4. I think 2 of them are to bring up different menus of messages, and all the messages are in the ROM. So if I switch 1 and reset, matrix display entertainment. Now let's switch 2 with switch 1 off. Matrix display retail, and both switches 1 and 2. Whoops. Matrix display general. Awesome. But with the blind back up, let's just have a quick look at these components. As I say, there's masses of dust on this. So yeah, Z80A CPU, EEPROM, RAM. LS138 is a 3-line to 8-line decode. So these will be the 3 lines and enable, presumably. What's this one up here? Oh, 245. So that's a bidirectional 8-bit buffer. So presumably the data bus on here is being buffered and then sent down this cable here. And this presumably is 3 lines which are being decoded and also sent down this cable, presumably to select the various registers on the other board, which is here. There's one of these, I think these are HCT 574s. They were the only flavor of 574 I could get, and I wanted the 8 lines in sequence so that I could maintain this bus, and then come through one of these ULN 2803 Darlington drivers, which actually pull, I think, columns of these LEDs through these resistors down to ground through the Darlington driver chip. Then this output from the CPU, which is a 20 or 24-way cable or something like that, runs underneath the board and then up to a connector here on the main display board. Why is that LED on? That's weird. I think it crashed. Oh, there's some weird fault with that. There's also a line of LEDs appearing on here, but I don't know. It's gone a bit intermittent. Anyway, this section here has 7 rows. Each of the rows has this transistor on it. Let's get a bit closer in on that. Yeah, that's a TIP 127. It's probably another Darlington. It might be a PNP for driving these rows. I can't remember. And there's a BC548 there to drive the, yeah, that's probably NPN driving the PNP Darlington. And there's actually a capacitor on there. It's hard to see, but it's these little yellow, now they're axial, are they? Yeah, I think they're axial. And the idea of that was that since you're multiplexing the 7 rows in turn, so it only turns on one of these 7 rows at any one time, these LEDs are being quite heavily overdriven in order to get them bright enough when they're only on 1 in 7, as it were. So we felt that if the CPU locked up and one of these rows latched on, we could blow LEDs or the driver circuits. So that capacitor on the input side means that you can only turn these rows on for a certain amount of time, and then they automatically shut off due to that capacitor. So it was a sort of CPU lockup failsafe. On the back of the main board, we couldn't work out a way at the time of having rows and columns on a single-sided board, and we wanted it single-sided for ease of construction. So what we ended up doing was having copper tracks on the board for the columns, and then actually soldering on, and I think that's why those rogue LEDs were coming on. I think I was shorting these wires with something on my desk. Actually soldering on these rows of wires, slightly stood off, and yes, apologies for all the dust on the back of this unit, slightly stood off the board and soldered onto a long leg on each of the LEDs to provide the row connections. Right, so to make up this cable, pin 1 I think is the arrow. Now you've got 10 pins and a 10-way ribbon cable. These are of course 100mm spacings, that's 100 thou, and these are 50mm spacings. So you've got this sort of staggered array of connectors in here, so that the 50mm spacings are then fed into these 2 rows of 100mm spacings. Pin 1 goes on to the brown wire, which seems logical because that's 1 in resistor color code. So I need pin 1 on here, which is that little arrow there, to go on the brown wire. So I think if I clip that on there, and I don't think it would matter which way up it goes, it could go that way or that way, it just has to be pressed on so that these little cutting barbs punch through the insulation, displace the insulation, that's why it's called IDC, insulation displacement connector, and touch onto the copper inside. So I just need a method of pressing that down, and I think I always used a vise. Right, that black connector seemed to have a part missing, but this one seems to have it on there, so I've got to try and lift out this top piece so that I can put it around this cable, but let's give that a try. Right, so pin 1 will be that way, so the cable needs to sit on top of there. Then I need to put this piece on the top and press it down as far as I can. I think that's correct. And now stick it in the vise. How am I going to hold this while I put it in the vise? I'm not entirely sure. Right, I've managed to just put that into the vise right at the top, And I think that's all lined up, so I'm just going to turn that, squeeze that thing closed. That should have made a connection, and there it is, ready to connect onto my keypad. Now, rather irritatingly perhaps, these plugs don't have the key that sits in that keyway, so pin 1 indexing, I mean, it doesn't really matter if I connect this cable the wrong way around, because the pins are simply wired in pairs, this end pair for this end key, and so on for the 5 pairs and onto there. So even if I get this upside down on one end and the other way up on the other, all that's going to happen is the keys will be reversed, so I can't really go that wrong. Now, I remember clear as the top 3. H, I'm sure, was just thumb. E, L, L, and O is the top one, I think. And then display is those 3, is it? No, maybe it's thumb and those 2. Yep, that's it. But that's USJJ OY. Oh, that's weird. Ah, that's probably because this is the wrong way around, isn't it? If I'm getting letters I'm not expecting. So let's turn that round and put that facing in upwards. Oh, that's without the indexing key. It's actually quite tricky. Right, so clear. Of course, that clear would be the same because it's the top 3. H, E, L, L, O, and then I'm sure the display was those 3. Oh, it is, but it didn't take the H for some reason. I've got E, L, L, O. Clear. Maybe H was those 2. H, E, L, L, O. Display. Hello! Excellent. Right, let's do my name. Now, I think J was sort of a vague J shape going around like that, so it might be that. U, I think it was something like cup of tea with your little finger or something. So U, L, I was one of these 2, but I can't remember, probably that one. And the A was the other one. And was N those 2? Honestly, can't remember. Display. Oh, that's not bad. Jolnat. Yeah, not bad. But I think we need the manual for this. Right, here's the manual. This is when I used to spell my name with a Y. Brett Gossage was the other chap involved in this project. It's quite a long manual, actually. And it goes into, well, it has all these lists of messages, and there are sort of graphics and different modes. This is the character set. These are the keypad keys that you have to press for each of the characters. So J was first one and last 2. I think that's what I did. Character set, and then lots of messages which are built in and which you can search for, but I can't remember the search procedure. Well, there's a search thing here. So first 3 and last does a search. So if I type in a letter like, for example, oh, let's do a clear, like an H, and then first 3 and last does a search. Oh, it's found a graphic of a house. That's weird. Right, I found a couple here. If I do an N and then a search, it says have, and it kind of appears statically and then scrolls off. Have a nice day. But there's another one which is in a different font, O. So let's do a clear. I think O is just the top one. Search. Yes, that's in a big wide font and says ladies and gentlemen, and just scrolls from right to left. Right, I've got the lighting a bit better now. So I found one that says this way. So that does appear better. Top 3 is clear. Let's find another one. Right, here's a good one. It's B, which is the last 3, and then search, which is first 3 and last. And that says beware of the dog. And interestingly, I think we wrote into the software that the longer the word, the longer it would hold, so that you can see there that beware holds for longer than of and the and dog. And the thinking behind that was simply that a longer word takes the brain longer to take in, I suppose. and so we held the long words for longer. Interesting. Now if I type in hello, HELLO, and display, I've currently got it set to wipe, but there are other modes here. There's a scroll left, which is, I think, E shift display. So let's try that. E shift display, and that sets display parameters. Then HELLO display. Oh yeah, that's scroll in from the right. I seem to have put in hell-ho rather than hello. Yeah, so I could do a scroll in, I could do an appear scroll left, and then a disappear scroll left. So that would be EE shift display. Let's try that. EE shift display, HELLO display. Yes, that's done it. So it scrolls in from, well, it does a left scroll for the appearance, holds for a while, and then does a left scroll for the disappearance. Let's try scroll in from the left and then scroll out back to the right. Right, so that one's EF, but I couldn't remember what F was, but it's the first four fingers. So I want EF shift display, HELLO display. Scroll in, scroll back out the other way. Cool beans. And let's try L search, and that's I heart my matrix display. Wow. Now there are some interesting beep sounds because there's a little piezo on the board. So if I search for something it won't find, search, you get a beep. Interestingly, if I press shift and search, you get a double beep. So there's various error codes built in here as well. If I search for something it will find, like just a letter, like say those two, we get 2, which is a one-shot. So I'm trying to find the retail message library. I think I've set the dip switches correctly for that. Message display retail, that's the one. And I want this one, hamburgers, hot dogs, cold drinks, ice cream. Here, that's cool. It's H search, hamburgers, hot dogs, cold drinks, ice cream, here. Cool. And that should repeat, I guess. Yes, it does. Now, the reason we had to have a lot of built-in messages was because there's no way to permanently store messages in here. We could have had battery-backed RAM. There's the RAM chip there. We could have put a battery on that, but it may not have lasted very long, depending on how much current that RAM chip takes. So we took the approach that we'd just have it, you have to key the messages in once you've booted the thing up. And we just decided to put lots and lots of messages in the EEPROM. We also gave instructions on how to burn an EEPROM and put your own messages in, of course, but that was fairly impractical because not many people would have an EEPROM programmer for that particular kind of EEPROM. No flash memory, of course, back in the early 90s, and you can see that this is dated April 93. There is a little bit of surface mount on here actually, which is pretty astonishing. If I can get the camera to focus, there it is. I think that's a little 555 germanium diode there, OA90 I think it is. Something to do with digitally enabling the 555 oscillator there. We felt the need to have a germanium diode, but yes, that's the little circuit that drives the piezo sounder on the other side of the board. And that's the piezo there. Of course, we could have used a self-oscillating piezo buzzer, but presumably back in the day, Maplin only had this non-self-oscillating buzzer. I think that's the pot to vary the piezo frequency to get a nice resonant frequency, so it's nice and loud. So there it is, a project from the 1990s, and I remember actually being quite proud of the CPU layout. This is on a single-sided board for the Z80, the clock and reset circuitry, decoder for the ROM and RAM. Actually, ROM and RAM is probably decoded with a single address bit. That's decoder probably for peripherals. I can't quite remember. Data bus buffer and this 3 to 8 line decoder for the 8 columns, rows. But yeah, quite a compact Z80 single-sided board. Yeah, I was quite happy with that. And yeah, quite happy that 20-something years later, put 12 volts on there and it still works. That's amazing. So yeah, that's brought back some memories. Cheerio.